Audio jack. Audio jack. Audio jack.
No problem.
Audio jack. Audio jack. Audio jack. Audio jack. Audio jack.
This is the green transmitter module in operation. We've got our transmitter, receiver. This is our signal conditioning circuit, and this is our 5-5 timer. So when the output, or sorry, the trigger on the 5-5 timer goes low, the output goes high, and that's what happens when I give a +1 to the transmitter. We get this momentary operation with a little blip there. We can also have a latching mode where it just stays on, and we could also have a toggle mode with the 5-5 timer also. We can also do something similar with this other module, which I call the quasar module. Transmitter, receiver, pulse data in there, and we can take the similar outputs. The signal conditioning circuit for this is slightly different. Even though they're very, very similar modules, they behave slightly differently. I have to have a slightly different circuit for signal control of that one. Now this is what I call the blue module, even though it's kind of green, but it's blue at the back. It's a QIA chip module. And you can save yourself an awful lot of hassle because you don't need a signal conditioning circuit or a 5-5 timer, because it's got encoders embedded in it. That's the transmitters, but it's got encoders there. And it's also got 4 channels. I'm just showing 2 of them here. So you can go for momentary operation, on off, and you can also go for toggle operation. So in toggle mode, you just go click on, click off, click on, click off. I think there's also a latching mode. Now, if you don't want the hassle of wiring this unit up to a relay, you can just get this little self-contained unit here. So you've got a fob here. It's kind of like a fob for your car. That's your transmitter. This is our receiver unit. You have receiver there, relay, capacitor, all sorts of stuff there that's probably tidying up the signal. So you can just do that. LED comes on, LED off, on, off, on, off. This only has 1 channel, so it's fine if you just want to turn something on and off at a distance. Bit of fun. But I must say I do like this little unit here. You've got 4 channels, you can control 4 different things.
Audio jack. Audio jack. Audio jack.
No problem.
Audio jack. Audio jack. Audio jack. Audio jack. Audio jack.
No problem.
Audio jack. Audio jack. Audio jack. Audio jack.
To clean up the signal, I'm using a half-wave rectifier, which is this one here. So when a voltage is applied at the input, what happens is we get our charge on our capacitor building up to maximum voltage, which in our case will be +5. And I've graphed the voltage input and the voltage output. That's a bit idealized of what our spiky one looks like, but it goes from 0 to 5 volts anyway. So when voltage input is rising from 0 to 5 volts, the capacitor charges up to its max charge of 5 volts. And then as the voltage input decreases from 5 to 0 volts, the capacitor discharges, as there is a potential difference between the capacitor voltage and the voltage input. However, the capacitor does not discharge instantaneously. There's a time delay that is dependent on the value of capacitance and resistance. So we get V out as we show here. So this represents our, it never goes to 0, and this is our time delay here, time delay here. This is the circuit diagram for the green module that I showed in demo earlier on. So what have we got? We've got the transmitter, we've got the receiver, we've got the 555 timer. At rest, as described earlier, the data from the pin on the receiver is this fuzzy signal that I had to clean up with this half-wave rectifier circuit with the resistor and capacitor showing here. So at rest, the pin 2 in the timer is high, so the output on the timer is low, so our LED is off. When we engage switch S1, it gives us 5 volts to data pin 3 on the transmitter, which sends the data pin on the receiver low, goes through here, and the pin on 2 is now low, which sets the timer high, and our LED goes on.